All right, new day, new laptop repair. And this time we have an XPS 9700, but let's see what's wrong with it. The customer said that he changed the battery following a YouTube video, and at first it would not turn on. It kept flashing between white and amber. He let it charge overnight. The next morning it wouldn't turn on at all, so please help. All right, so let's figure out what we got here. So XPS 9700, this is a 17-inch laptop. Here's what we'll do first, is let's plug in the charger real quick. And we got 20 volt negotiation, no current being drawn. Let's try another port. 20 volts. So the PD controller is working. The PD controller is actually negotiating the voltage, but the laptop is not taking the voltage. So that could be a power management chip or something like that. Let's take a look and see if it powers on. We got an orange light, so that usually means the battery's dead. We'll plug this back in. Okay, I'm gonna hit the power button. Nothing happens. The current doesn't change either. You can't really see that. Let's see, let me use this camera. See if you'll be able to see it with this camera. There you go. Okay. So it's not pulling any current from here. We don't have an orange light anymore. I'm going to press the power button and see if it changes. I don't see anything changing. 0.03. That is basically just the EC chip powering up, so it's not enough current for anything to happen. Oh, I'm seeing the screen kind of flash for a second, actually. I don't know if you can see that. It's like the backlight's coming on temporarily and turning back off. That's interesting. We're gonna have to open the bottom up and figure out what's going on. Since he changed the battery out, we don't know what he did, if he unplugged anything else in there. So let's open up the bottom here. Okay, these bottoms are hard to get off, but since it's been off at one point, it makes it a lot easier. Okay, and so we have it open. So let's take a look here. Here's the battery. It looks like it is a genuine OEM battery. It does have a serial number here. That's something that's important to know because these aftermarket batteries have an issue. This battery is just like a pull latch here. You can see that connector. It's a little bit different than any of the other batteries that go to this. The first thing I'm going to do is actually just grab a test battery because I have some of these as test batteries, so I can just grab one. All right, here we go. So I have a test battery. What we're trying to test here is to figure out if the laptop will still power on off the battery. Okay, got the battery out. This is his battery. Plug this in. I actually don't know if there's a charge on this, but we can figure it out pretty quick. Not seeing anything happen there. All right, here's what we'll have to do because I don't think this battery's charged. I'll grab a test board, which I have lots of motherboards there. And this board is the same model or same type generation. I'm gonna plug it in here and we'll plug it in and just let it charge up for a little bit. So I've let this battery charge for a little bit. So let's see how charged it is and see if we can power up this system here. So here's the customer's laptop. I'll go ahead and install his battery back in there. We'll see if we can get his laptop to power up off of his battery now that it's charged a little bit. I don't see any lights yet. Charger's not doing anything. There we go. We do have lights here. Let's see if it's a light code of some sort. 1, 2, 3. 1, 2, 3, 4, 5. 3, 5. All right. Light codes for XPS 9700. And this says 3.5 power rail failure. So I was wrong. It's not a BIOS, it's a power rail failure. All right, so we got to figure out which power rail has actually failed. Let me go ahead and get this board pulled out. And that way we can start doing our measurements. Actually, I may not pull out the board. I'm just gonna take the heatsink off and we'll pull the hard drive, and that way we can get down to it. We might be able to not have to pull the board out. You know what's interesting is that I see something. Ooh, I did not see that earlier. Okay. All right. Okay, all right. So, you remember earlier how I talked about how it's hard to get this off? And it came off pretty easily, and it's because it had been opened before. Take a look at this. I don't know if you're gonna be able to see it, but look right here. You see this is dented in, this is dented in, this is dented in, this is dented in. The fins are dented. I'm assuming that somebody was trying to pry the bottom off by sticking a screwdriver in here, or something like that. That's the only thing I can think of, and I bet that that bent something that's shorting something out. Because seeing these on here, this is pretty crazy. See those bends there? So let's pull this heatsink off. Let's figure it out. All right, got it. And it's off. All right, you can get a closer look at this. So this heatsink will need to be replaced. That's no longer usable. See if we can get the focus. Thermal paste, I think this is the original thermal paste. I don't think it's been changed. See, that actually is pretty dusty, so I don't think he has opened it up to clean it. Let's see if we can clean that out. I think I could send this over to the greatest technician. Do you think he wants this stuff? I'll collect it over here. We can mail it off to him tomorrow. Okay, so let's go ahead and take a look at these power rails real quick. If something is shorted, it should be pretty noticeable. So I'm putting this probe in beep mode. So one on ground, and I'm just gonna check some of these coils here. That one's fine. So you can see right there. Nothing here. 35 ohms. Oh, is it? 35 ohms is probably okay for that. This one's okay. What about over here? So this is going to be a 3 and 5 volt rail over here. So let's go measure that. That one's fine. That one's fine. And then I think there's another 3 and 5 volt over here too, because each side has its own. There they are. And I'm not seeing anything shorted here. Let's go ahead and plug the charger in now that we have the heatsink taken off. I mean, the heatsink could have been bent in a way that was actually shorting out some of these parts here, so let's check that. All right, got it plugged in. Still not charging, but we don't have a battery in there actually, so let's see if it starts charging. Just looking here, just seeing if any current changes. Nope. All right, I'm just gonna measure some voltages. So put this on volts. Got 0 volts in the 3, 0 volts in the 5. I think this is the main power rail. Nope. Got 0, 0, 0 everywhere. I need to pull this board out. There's nothing I can do trying to do this. So give me a second. Okay, and the board is out. So let's go ahead and do some measurements real quick. Now that we have the board out, it will turn on by itself. First, you must reset. If it is going to turn on. And I don't see anything happening here. Let's do a physical inspection. Make sure we don't have any blown out components or anything like that. Okay, I'm just looking around the board. What I'm looking for is anything that looks suspicious. It could be a burnt, it could be a spill, it could be a burn, but since he changed the battery out and there's a missing power rail, it's most likely going to be some sort of shorted component, which could be a cracked capacitor even. I don't see anything so far. Just gonna keep looking around. All this looks fine. Check the other side again one more time. This is where all the actual power components are. There's a switch there. So we're going to have to look around to see if there's a shorted rail. Alright, so I'm going to go back to beat mode. Continuity mode. What I'm going to do is I'm going to look over here real quick. Just going to check some of these capacitors over here. That's fine. That's fine. Fine. That's fine. Let's look over here. So this is the same setup. You can see it looks the same as over here. Where's it at? Right here. See? This board's set up where it has it on both sides. So I think positives on that side. Okay, so let's check this. Another audio chip here. Everything's fine on the audio chips. Let's check this current sense resistor. See, most likely there's no short, but we need to figure out which power rail is not actually coming up. Alright, so the input circuit is right here. Alright, let's see if we have the main power rail. So these are the MOSFETs that power this GPU here. And these capacitors will be on the main power rail. And we've got 0.8 volts on the main power rail. I would say that's not enough.
So we do have those in stock.
I would say that's not enough. We do have 20 volts here. 20 volts coming into this MOSFET. 20 volts coming out of this MOSFET? Nope. Okay, so this... Do we have 20 volts going into this one too? So 20 volts is here, and that goes into here, and then that's going to come out. And it looks like that powers... Oh, this is ground right here. So, and then this will go... And then we got 0.5 volts on this side. What do we have on this gate? What do we have on the gate on this one? 0. Alright, so this power management chip is what's actually going to be using, taking the voltage from the charger, from the USB-C, and then it will be controlling the MOSFETs to create a main power rail, and then it will also charge the battery. So let's see what we can get in measurements there. I actually have more of these chips if we need to replace it. Got 19 volts coming in. 19 volts should be there, I think. 20 volts, yep. I mean, this is all looking fine here. I'm pretty sure we're supposed to have 5 volts here. So why we don't have 5 volts, I don't know. So let's figure out if we can figure out what's supposed to be on that. So what I'm going to do is I'm going to take a board that works, a functioning board. Alright, so here's a functioning board. That way we can figure out what voltages is supposed to be on that pin. So we're going to measure here, we got 20. And what do we have here? 4 volts? Yeah, what about here? 3.3, so we're missing 3.3, 3.3. So let's go back to the other board. So this chip's not getting the 3.3. So we measure right here. Oh, we have a 3.3. How do we miss that? This one's not 3.3 though.
Yeah.
Alright, let's figure out where those voltage sources are being generated, created. So here's the customer's board again. And let me see if I can pull up the board view schematics. Alright, it's another day. I had to end yesterday. I didn't have much time. Okay, so let's continue looking at this. We were looking at the power management chip because we measured. We have 20 volts going to the chip, 20 volts going in, and then on our other board that we were testing, we had 3.4 here, but we don't have that. That's missing. We have 3.3 3.3. We're supposed to have 3.3 on all these. This one's not supposed to have anything. And then... and 3.3 on this one. So we're actually missing 3.3 all the way across here. 24. I think this chip's bad. I think we're just going to change this chip out. That'd be the easiest route to start with. These things go out. And I have more of them. So... yep, 2 left. There it is. Alright, so let's remove this chip and move it over. You can see these pins are getting shiny here. So the pins are shiny. Should be almost ready to come off. Those two are still not shiny. There we go, they're about to be. There we go, it's getting loose. And it's out. Let's put some fresh solder on those pads. This is a lower temperature solder. Better quality. Don't want much in the middle. Again, we're just going to heat this until everything gets shiny, and then we'll be able to set that down. You see how the pins are getting, all the solder's getting melted and becomes shiny. Set this down. There we go. We'll add a little bit of flux. There we go, it just seeds itself. Okay, that's soldered on. Let's go ahead and clean it up, cool it down a little bit, and then we'll give it a try. Okay, let's plug it in and see what we get. Let's go ahead and measure around that chip. See if we have that 3.3 or if it's still missing. Still don't have the 3.3 here. Or the 3.7 there. We got our 20 here. Still got the 5 volt there. 5 volt. We have the 5 volt here still. Got 5 volt going in there. So the issue is not in this area. So that chip is actually fine. I'll probably end up putting it back on. All right. So here's what I've figured out so far. So all the power rails actually are present, but for a short period of time. So if I plug it in and I measure the main power rail, we get 13.3. If I measure the 5 volt, we have 5 volt. If I measure 3.3, we got 3.3. If I measure the 1.2 for the memory, we got 1.2. If I measure the chipset, we got the chipset. Hold on, let me start it over again because it only lasts for a few minutes and then it shuts off for a few seconds. So I'm going to plug it back in. Chipset's up. Memory's up. So all of them are working and then it will shut off. So, but if we'll just stay on the main power rail here. 11.8. This is actually be 13.6. And see it drops off. And then now it's dead. So I'm going to reset it. Plug it back in again. .56 goes down to 10, goes to 13.2, then it starts dropping down again. 11.86, and it sits there for a little while, and then that whole power rail shuts off. There you go. And now the board's off again. So the power rails all work, except the main power rail keeps shutting off. Why is that? So if we take a look at these two MOSFETs, and this coil is what produces the main power rail from the 20 volts coming in through here, through this current sense resistor. And so if I measure right here, which is the output of this MOSFET, get the 12.86, I mean 13.3, and then it starts dropping down. But what I'm interested in is what's on this gate pin here, because the gate pin is what dictates how much voltage is going to come out of this. So I'm going to reset it again. This should be higher than what we need. So it's 12. It only gets up to 13. Then stays at 11. So ideally, that pin should actually be like at 16 or 17 volts to allow the 13 to be able to come out of here. So there's a chance that this MOSFET is actually shorted to that pin, to that gate. So let's go ahead and measure and see if we have a short across these. And we do have a short. Let me measure this one too. This one, the resistance low, and then going back up. So we'll go back to this one. This MOSFET's probably shorted out, and that's what's causing this gate pin to stay the same voltage right as it turns on. This actually should be higher to allow more to come out. So let's replace this. All right, the solder's starting to melt. You can see it there. So it should be loose. Okay, and it's out. We are going to install one of these in channel. It's going to go that way. Okay, let's see. Is it going to work? Still nada. Still nada. Reset the charger and see if we can get that same 13 volts there. 12.55. 13.3 drops down to 11. Same. And so we've already replaced the power management chip on this. So what component over here is causing the issue? I'm going to look around again for a short, because there's something that's preventing that it's like sensing that there's an issue, and so it's not allowing the voltage to get there. I mean, the fact that this happened after the guy changed the battery, it's very interesting. But I kind of want to get a story to figure out why he was changing the battery, because that could have something to do with it. Looking around the board, see if we see anything out of place.
It actually goes with.
And what do we have here? This component that got ripped off the board here. Looks like this pad's missing completely. This will definitely cause an issue. How did this get ripped off? I'm not sure. This doesn't make sense. Because remember, we saw this damage here. The heatsink was bent from a screwdriver prying it off. But this heatsink goes on like this, and this motherboard installs like this. So the broken component is underneath this. Okay, let's take a look. I don't see anything per se. So it would have been like right around here. I don't see any big pry marks, but I can imagine if a screwdriver was shoved in there deep enough, it would end up prying underneath the motherboard right here. All right, let's replace that component and see if we get this board to boot up. Hopefully one of my donor boards has this chip. Let's see what we got. The donor board I have, look at this hole. Wow. That's why this is a donor board. It's a little different in this area. Looks like it's the same setup here. Resistor, 2 pads here. Yeah, I think that's the right one. So let me go ahead and prep the area real quick. So this will need to be, we'll need to put a new pad on this. So let's go ahead and do that real quick. So So what I'll need to do is I'll scratch this away to reveal something to solder to. Like that. Sure. Okay, I'm gonna break off this extra little piece here. That. Clean these rest of these pens. With fresh solder. Okay, ready to go. Let's put the new chip on. So I'm gonna steal it off this other board that has a hole in it. Okay, we got it. We got it. Let's go ahead and clean this up a little bit. Ooh, okay. Okay. Let's see if it works now. Okay, you ready? Here we go. Moment of truth.
Liz, go. 37, so.
And look, it's pulling current. Look at that. All right. The board looks like it's posting, so let's go ahead and get it reassembled in there. All right, it's back together. Let's see if it works. Let's see if it works. Plug in the charger. At 20 volts. Got a Dell screen for a second. And we have the Dell screen. Let's go into the BIOS. Almost 5 amps now. Charging the battery and running the laptop at the same time. All right, AC adapter is detected. Battery's at 25%. Let's unplug the charger and see if it stays on. It stays on. Okay, so that means that everything got fixed on this. So to recap, we weren't getting the main power rail to stay on. I tried changing out the power management chip. That didn't fix it. We tried changing out that first MOSFET. Because the gate pin, it looked like it was shorted out, but it definitely was not the issue. And after another inspection of the board, which I missed on the first time around, whenever you inspect the board, you should be looking for these components that have fallen off or got ripped off the board. But whenever the person had opened up the bottom and was trying to pry the bottom off, they pried on the board and ripped that component off. Which was a crucial component to actually start up the board. So we got that changed out, and now everything's working. Thanks for watching. See you next time.